Hello friends, welcome to Bindu Dhadwal Chemistry Lessons. The topic that we do today is Group 18 elements, noble gases. The elements are helium, neon, argon, krypton, xenon, radon and oganesson. These noble gases, they are found in atmosphere up to 1% and as a main constituent of various minerals such as pitchblende, monazite, cliffsite. Helium and neon are also found as a constituent. The helium is also found as a constituent of natural gases. Radon is found by decay of radium 88-226 and oganesson can be formed in the laboratory by colliding calcium with californium. Half-life of oganesson is very less, 0.7 milliseconds, so it's not found in nature as such. These noble gases are very unreactive because they have a stable configuration of NH2, NP6, except for helium, which has a stable configuration of 1s2. The ionization enthalpy, due to stable electronic configuration, these gases exhibit very high ionization enthalpy. It decreases down the group with increase in atomic size. The atomic radius also increases down the group with increase in atomic number. The electron gain enthalpy, as they have a stable electronic configuration, they have no tendency to accept the electron and therefore have large positive values of electron gain enthalpy. Physical properties, these gases are monoatomic, colorless, odorless and tasteless. They are sparingly soluble in water. They have very low melting and boiling points because the interaction in these elements are weak dispersion forces. Helium has the lowest boiling point, 4.2 Kelvin, of any known substance. It has unusual property of diffusing through most commonly used laboratory materials such as rubber, glass or plastic, so we have difficulty storing them. Chemical properties, noble gases are least reactive elements because they have completely failed NS2 NP6 configuration except for helium, which has 1s2 in their valence shell. They have high ionization enthalpy and more positive electron gain enthalpy. In March 1962, Neil Bartlett observed the reaction of noble gas. He prepared oxygen hexafluoroplatinate and then he realized that first ionization enthalpy value for molecular oxygen 1175 is very close to that of xenon, 1170 kilojoules. So he tried to prepare the compound of xenon with platinum hexafluoride and he was successful. A red colored compound of xenon hexafluoroplatinate was formed. Compounds of krypton are fewer in number. Krypton difluoride its properties has been studied. Radon difluoride has been identified but not isolated, and no true compound of argon, neon or helium are known. Xenon fluoride compounds can be formed by direct reaction between xenon and fluorine. When xenon is in excess, xenon difluoride is formed at a temperature of 673 Kelvin and pressure of 1 bar. When xenon and fluorine are mixed in a ratio of 1:5 at 273 Kelvin and 7 bar pressure, xenon tetrafluoride is formed, and in the 1:20 ratio at temperature of 573 Kelvin and 60 to 70 bar pressure, xenon hexafluoride is formed. Xenon hexafluoride can also be prepared by interaction of xenon tetrafluoride and oxygen difluoride at 143 Kelvin. Xenon difluoride, tetrafluoride and hexafluoride are colorless crystalline solids and sublime readily at 296 Kelvin. They are powerful fluorinating agents. They are readily hydrolyzed by traces of water. For example, xenon difluoride plus water will form xenon plus HF plus oxygen. The structures, xenon difluoride is linear. Actually the hybridization is sp3d, but and the structure should be trigonal bipyramidal, but the equatorial positions are occupied by valence electron pairs, so the structure is reduced to linear. Similarly, xenon tetrafluoride should be octahedral, but it's square planar because the axial orbitals are occupied by lone pair of electrons. Then xenon hexafluoride is distorted octahedral because 7 electron pairs, out of 7 electron pairs, 1 is valence electron pair. Xenon oxytetrafluoride is square pyramidal because of the octahedral geometry that it should have had. 1 is lone pair of electrons. Then xenon trioxide is tetrahedral in nature, but because 1 lone pair of electron is there, so geometry is reduced to pyramidal. Xenon fluorides react with fluoride ion acceptors to form cationic species and fluoride ion donors to form fluoroanions. For example, XeF2 plus PF5. PF5 accepts an fluorine to form xenon fluoromonopositive and phosphorus hexafluoride ion complex. Xenon hexafluoride will react with metal fluoride, which is a donor, to form metal tetrafluoroxenate. Here metal can be sodium, potassium, rubidium or cesium. Xenon oxygen compounds. Hydrolysis of xenon tetrafluoride and xenon hexafluoride with water gives xenon trioxide. Xenon tetrafluoride plus 12 water will give xenon plus xenon trioxide plus HF and oxygen, and xenon hexafluoride plus 3 water will give xenon trioxide and HF. Partial hydrolysis of xenon hexafluoride gives oxyfluorides XeOF4 and XeO2F2. So these are the reactions. Xenon hexafluoride plus water gives xenon oxytetrafluoride plus HF, and xenon hexafluoride plus 2 water gives xenon dioxy difluoride plus 4HF. Xenon trioxide is a colorless explosive solid and has a pyramidal molecular structure, whereas xenon oxytetrafluoride is colorless volatile solid and has a square pyramidal molecular structure. This is square pyramidal structure. Uses of noble gases. Helium. Helium is non-inflammable and light gas. It's used in filling balloons for meteorological observations. It is also used in gas-cool nuclear reactions. Liquid helium, boiling point 4.2 Kelvin, finds its use in cryogenic agent for carrying out various experiments at low temperatures. It is used to produce and sustain powerful superconducting magnets, which form an essential part of modern NMR spectrometers and magnetic resonance imaging systems for clinical diagnosis. Helium is also used as diluent for oxygen in moderate diving apparatus because of its very low solubility in blood. Earlier nitrogen was used, but it causes cramps in divers. Neon is used in discharge tubes and fluorescent bulbs for advertisement display purposes. Neon bulbs are used in botanical gardens and in greenhouses. Argon is used to provide inert atmosphere in high temperature metallurgical processes like arc welding of metals or alloys and for filling electric bulbs. It is also used in laboratory for handling substances that are air sensitive. Xenon and krypton are used in light bulbs designed for special purposes. So this is the end of P block elements and of noble gases.